Hi everyone, I hope you're okay, and I really hope that guys the videos will keep uploading and helping you out. This is the 23rd video, which simply means I'm doing question number 23. Please do expect a total number of 33 questions, of which guys each and every question will have its own video. Organic chemistry guys, it's a huge chapter, so be patient with us. There will be more videos, not rather more, many videos will be uploaded rather, relating to organic chemistry. Okay, let's just get right into this question. Petrol is a mixture of hydrocarbons, many of which have the molecular formula of C8H18. Okay, I don't know whether you guys have noticed that maybe whenever you go to the petrol station to pour some petrol, they ask you that do you want 95% or 93%? What do they basically mean? For the 95%, it simply means that that petrol has 95% of pure octane. Are you together? And then the other 5% just represent the isomers of octane. Are you together? And then for the 93% petrol, it simply means that you have 93% pure octane, and then the other 7%, it's just the isomers of octane. Are you together? They are isomers because all of them have this molecular formula. Okay, let's just get right into it. 4.1, write down the name of the homologous series to which hydrocarbons with this molecular formula belong. The homologous series, those are alkanes. Are you together? The general formula for alkanes, it simply says CnH2n plus 2. So if the value of n is 8, that means I'll simply have C8H 2 multiplied by 8 will be 16 plus 2, I'll get 18. So the general formula for alkanes is this one, and hence the compounds with this molecular formula belongs to alkanes. The structures of two compounds with molecular formula CH18 are given below. Compound A, we are given a branched structure. So this will be the parent chain. That will be carbon number 1, 2, 3, 4, 5, and 6. Okay, the IUPAC name for this will be 2.2 dimethyl. On my parent chain, I have 6 carbons, so this will be hexane. Okay, and then for compound P, I only have straight chain hydrocarbon, so this will be carbon number 1, 2, 3, 4, 5, 6, 7, 8. This is just octane. Okay, 4.2. Why are compounds A and B structural isomers? They are structural isomers of each other because they have the same molecular formula but different structural formula. Are you together? If you can check, both of these compounds have a molecular formula of C8H18. They have the same molecular formula but different structural formula. That's why they are isomers of each other. Okay, and then 4.3, which one of the above compounds, A or B, has a higher boiling point? Refer to molecular structure, intermolecular forces, and the energy needed to explain your answer. Okay, we are comparing compound B and compound A, right? My reference point will be compound B. Okay, first I need to say both compounds have the same molecular size. Since they have the same molecular formula, right? So if you were to calculate the relative atomic mass number for both compounds, you're going to get the same answer. They have the same molecular size. However, compound B has a greater surface area. A greater surface area. When I'm comparing these two compounds, compound B has more width compared to compound A. Compound A has only 6 carbons. Compound B has 8 carbons on the parent chain. Are you together? So since compound B has more width, we say that it has a greater surface area. Are you together? It has a greater surface area. Okay, so this thing simply means that compound B has stronger intermolecular forces. And hence compound B requires more energy to separate the bonds. Separate the bonds, and therefore compound B has a higher boiling point. Compound B has a higher boiling point. Okay. That's how, guys. That's how you're supposed to answer this question. Eh? We are contrasting between two compounds. I made compound B my reference. That means I was just going to talk about compound B. If I wanted to make compound A my reference, I would have said, yes, both compounds have the same molecular size. Excuse me. However, compound A has a smaller surface area compared to compound B. Are you together? So since compound A has a smaller surface area, point number 2 would have been compound A has weaker intermolecular forces compared to compound B. And my third point would have been compound A will require less energy to separate the bonds. And then my last point would be, hence compound A has a lower boiling point compared to compound B. It's up to you guys. Just pick which compound you are going to talk about, but just know that you must talk about, firstly you must identify the difference on your first point. Second point, do talk about the intermolecular forces. Third point, talk about the energy, and then on your last point, on your last point, just conclude your observation. Okay, so now let's move to question 4.4. We are told that compounds A and B can be prepared or can be used to prepare smaller hydrocarbons at a high temperature in the presence of a catalyst. Okay, in the presence of a catalyst, one such reaction is represented by the incomplete equation below. Write down the name of the reaction represented above. This type of reaction, guys, it's called cracking. Cracking is the breaking down of large hydrocarbon compounds, breaking them down into smaller hydrocarbons. So please note that, guys. Okay, for the second question, they want us to write the structural formula of compound C. Firstly, we must know the molecular formula of compound C before we can write the structural formula. The equation has to be balanced, guys. The number of carbons which are present on the left hand side should be equal to the number of carbons which are present on the right hand side, right? We had 8 carbons on the left hand side, but now we have 5 carbons over there. That means compound C has 3 carbons. And then the hydrogens, we had 18 hydrogens, and then we have 12 hydrogens there. That means compound C we'll have 6 hydrogens. And then now if you can calculate the number of carbons on the left hand side is the same as the number of carbons on the right hand side, same applies with hydrogens. The number of hydrogens on the left hand side is the same as the number of hydrogens on the right hand side. So this molecular formula represents an alkene that has 3 carbons. So the structural formula for that alkene, it's just easy. You're dealing with prop 1-ene, or just say propene. There's no any other propene than prop 1-ene. Propene. That's how you're supposed to tackle question 4.4.2. And then the last question, we are being asked to balance, we are being asked to write down the balanced equation using molecular formula for the complete combustion of a pentane. Complete combustion, let me write properly, C5H12. We are reacting, we are basically oxidizing this alkane, and for complete combustion we will forever form carbon dioxide and water. By just getting these correct, guys, by just writing this thing over here, you already have 2 marks. The other mark you'll get it for balancing the equation. By writing this and adding oxygen over there, you already have 2 marks out of 3 together. So the other mark will be from balancing the equation. Let's balance the equation. How many carbons do we have on the left hand side? We have 5 carbons. That means we must write a 5 there as a coefficient. How many hydrogens? We have 12. Over there we have 2. I know that 6 times 2 will give me 12. So how many oxygens do we have on our right hand side? We simply have 10 plus 6, which will give us 16. The coefficient of oxygen there should always be half of the number of oxygens which is found on the right hand side. So since I have 16 oxygens, that means I must write 8 over there. Now let me check. I have 5 carbons on my left hand side, 5 carbons on my right hand side, 12 hydrogens on my left hand side, 12 hydrogens on my right hand side, and then 16 oxygens on my left hand side. I also have 16 oxygens on my right hand side. So now the equation is balanced. And then you'll get your full 3 marks. Thank you for your time, guys. I really hope the videos are helping you out. Just stay tuned, guys, and wait for more videos. Bye.